Good day, guys. Thank you. So actually, you heard today that for the Daniel to admit his own mistakes took 17 years, right? So for me, I really wanted to share that sooner. So the lessons which I learned and we as Kubernetes Technologies learned. So good day, guys. I'm Justinas Kuizinas. I'm the CTO of Kubernetes Technologies. I'm also a local meetups organizer. But I won't spend much time describing myself. Here is the LinkedIn QR code. So be sure to connect, share, write feedback of mine. And good thing about today's morning presentations about companies is that I don't need to introduce Kubernetes Technologies as well. So more time for the presentation. This is even better. So yeah, the lessons which I knew, I wish I knew them before the migration from the on-premises to the cloud. And interesting thing is that the talk after my talk will be also related. So I believe this will be a good hour of migration topics. So let's start. What is the history behind this, action? So we are working with a client for almost a year, and we are working on a modular Django system. And basically, that system was consisting of 10 various sizes and versions Django platforms, ranging from Django 1.6 to Django 3.2. So the various versions, various sizes. So it was pretty interesting platform. And the platform itself was being used by quite a big company, and that company's functions, all the everyday activities were being used from this platform. So all the customers, invoices, ERP systems, clients, everyone was using this platform. So basically, it was core of the business. And we are working on premises infrastructure with limited permissions. And basically, this was our history, how we started working with this client. But after working for several months, we actually started seeing several problems. And once we join a project, we are not very keen, on changing everything from the ground up. We start investigating, we start seeing problems, we start listing them. And after a while, after some investigations, we started seeing that actually it's not a very modular system, It's not like different Django platforms working on. It's actually modular architecture, but using one database. At the end of the day, we found out that it's only a distributed monolith. And as you can see from the schema, we just tried to draw a very similar, very principled schema, that all those Django systems, although the initial idea was pretty good behind it, once one monolith started growing up, the developers decided to start splitting that up based on the domains, based on the functionalities. But the execution plan was not actually very good, because they still left one connection with the central MySQL database. So at the end of the day, what we ended up having, 10 Django projects, everyone having their own database, PostgreSQL, but still linking up through the MySQL database. The infrastructure side was also pretty interesting. We had 2 bare metal servers, and which were barely used. You will see that in the next slides. And basically, there was no vertical scaling, no high availability, no visibility of a platform. At some point, we are feeling like blind kittens, inside the infrastructure. All the deployments were done with the processes of the UWS GI, Junicorn, and no Dockerization. So, and the platform provider, the infrastructure provider, was also not very communicating, not even talking, about the actual jobs which could be done with the infrastructure. And yet, yes, we had no auto deployments. So from this, actually, these are the screenshots which I did, while investigating the platform. And what we spotted that, for example, this is one of the schemas, one of the monitoring information from one of the bare metal servers. And you can see that CPU idle time averaged at 90%. So basically, this means that 10% of the time, the infrastructure was not even used. And the cost for the bare metal was constant, but still pretty huge compared with the for such usage platforms, what could be loaded up. And talking about the memory, the situation was pretty similar. Only 20% of the memory was being used on one of the servers. So actually having this information in mind, we started raising questions, In case we have an infrastructure where we have very limited, not even, from maintainability point of view, but also, from the deployments point of view, we don't have much access. We have over-resourced infrastructure. And even at those spikes, the infrastructure is still working at 100%. This means that, it's still lagging, right? What are the solutions? Journey to the cloud. Actually, the client was also pretty interested. It had quite a lot of information about the cloud. But, we're not likely to go always and to say, we have to go to the cloud. There must always be some arguments, why we need to go to the cloud, What are the main arguments? What would be the benefits of going to the cloud? So firstly, scalability. From this platform's perspective, maybe not the scale up was more interesting, but the scale down, because the system itself was not working at constantly at the full capacity, It was working only on spikes. So scalability would definitely help to solve this problem. High availability. During the week, there was constant outages, like several a week, and good thing when those outages appear on a workday. But in case they appear on weekends, on evenings, the client system then gets paralyzed. So this was also quite a problem from the business. Manageability, as I mentioned before, we had very little hands-on on the infrastructure and very limited access. Cost. Not only from the infrastructural point of view, but also from the development point of view. Because while developing and supporting the system, we had always to think about how this will work on the production, And to replicate that, even the dev environment wasn't the exact replica. So we had always to think about how that will work on the production, and at the end of the day, we still will have some problems while after deploying to the production. And last but definitely not least, the security. Because we started with this client from the audit, not only the code audit, but also infrastructure audit. And we saw quite big holes in the security, starting with open ports to the database, not secure ports, not even talking about the versions of the infrastructures, and so on and so forth. So definitely there was some job needed to be done on this perspective. And our suggestion was to think about the AWS. First of all, we have the most experience in the AWS. We previously did successful migrations to the AWS. And yeah, probably the side note, very, very small point, but it's the leading cloud provider in the world. So yeah, basically the AWS was a go-to solution which we offered to the clients. But the next big question which we discussed was, should it be a gradual one or the big bang? The gradual, on the one side, it's safer. We can control it, and in case something goes wrong, there is a very little impact, it's controllable impact. So this is a good thing. But on the other side, the big bang is a little bit easier, because you don't need to always keep up to date with the gradual migration, how will that work with the existing infrastructure? So it's easier, you just turn everything off and start everything on the new infrastructure. Pretty easy on the one note. And it's a bit cheaper from the preparations, because you don't need to, as I mentioned before, to maintain both of the infrastructures, right? You just turn one off and turn another one on. And after having discussions with the client, because the client was very cost-oriented and had very limited costs, after providing the estimates for both gradual and the big bang, we decided to go with the big bang, mainly because of the cost and the timeline on which I put up the migration plan. And we started the preparations phase for the big bang. So whenever I start some investigations about migrations or other jobs on the infrastructure, I would like to have some kind of a plan. So firstly, we started with the discovery and planning. So resource and scalability evaluation per system, just to have the information on basically on every platform what resources will be needed, how will they be able to scale up. And since previously the scalability was not a thing, because everything was just deployed in the bare metal, we also needed to investigate this one as well, how the platform, every single Django platform, will react after scaling it up. So this really needed some discovery phase. Integrations. Quite an interesting thing because we had the list of integrations, but after digging it deeper, about the integrations which I needed, which are crucial ones, we even started finding new integrations which were totally forgotten by the client. So after finding these integrations, they were very different. For example, one integrations needed to push the data. Other integrations needed to pull the data. Other integrations needed to create a file and to upload it on the other platform. So this also required planning. And another thing was, if you remember, I mentioned that there were all the links to the central MySQL database service, right? So our idea was, with the planning phase, whenever possible, try to remove those direct links. Because while doing the migration, they are the ones which you can hardly test on one platform, right? You have to deploy the full picture, and only then you will see whether those links to the MySQL works or not. So our idea was try to eliminate them wherever possible, and in case it won't affect the business critical functions, it won't affect the main platform runtime. And at the end of the day, we started creating migration plan. So the preparation, we started the preparation with the Kubernetes setup, namespaces setup, AWS preparation, accounts, organizations, IAM policies, networking, so on and so forth. We introduced S3 buckets, a simple storage service for storing the files on the cloud. We introduced Terraforms. We're really fans of Terraforms. Terraforms are the infrastructure as a code. So you define all your infrastructure in a code in a file, and you're pretty sure that every time you deploy, it will be deployed as you have defined. There is no error for the manual input. So this really helped us not only to deploy development and to easily have production environment with the same definition, but also to have the applicability to create new environments with a matter of a click. Monitoring and logging. Since we didn't have that previously, we really put most of the emphasis on that. And continuous delivery. Because while shipping, we don't want to think about the infrastructure, about manual actions. This was also quite an important thing to note. Then we moved to the test phase. Basically, create the staging environment, load everything up, try to test and verify, load test that, pass to the clients to also verify that from the client side. And the last step, the migration, right? Stop all the infrastructure, dump and load the data to the production environment, start new infrastructure, and verify. So far, so good, but with the planning phase, we didn't come to the last step because we had the change of plans. This was actually mainly influenced by 3 points. First point was unstable testings on a migrated development environment. After starting testing, we evaluated that especially those links to the MySQL are very unstable. It's pretty hard to monitor them. It's pretty hard to find what went wrong. And also the client started pushing for results from above requirements. And while having those points in mind, and after having the development environment, we found out that the rollback of such huge platform and such a huge migration would be way too hard and way too risky. So basically this led to one outcome, to one decision, to migrate only the databases. Yes, it's still quite stop and start procedure, right? It's not very gradual, but this would really help us to have everything on the cloud, all the data on the cloud, and to later on start with the gradual migration of the applications itself. So the deployment day, right? The D-Day, everything is in place. All the plan is in place. Everything knows their purpose, what they are aware of, what they are responsible for. What could possibly go wrong, right? The famous last words. The next sunny morning, we found out that exactly at 8 a.m., the deadlock started appearing. For the lucky of you who are not aware about deadlocks, the deadlocks in the databases are once several transactions are blocking each other. So it kind of creates the circular dependency, right? So I really hope that you will not have a chance to meet them. But yeah, deadlocks started appearing in the MySQL. 503s, bad gateways, started coming from some applications occasionally. But we still managed to hotfix those biggest problems, right? To stabilize the situation, to resume the business work. But still, those deadlocks were the thing which were worried us the most. And we raised the question and our suggestion to migrate back, but there was a decline from the client, mainly because 1 hour basically shutdown of a system while we load up and while we dump and load the new data of a morning was not possible. So while having this in mind, we still focused on the hot fixes of the main flows of the platform. And by the end of the day, it seemed like the situation was under control, right? The client was pretty happy. From the monitorings, we still see that, yes, there are some deadlocks, but you know, they are not affecting business. So we started with lower priorities, focus on the high priority tasks and the problems. Let's fast forward 5 days, right? So we already think that the migration is done. We are happy. All of us are pretty happy. But we receive more updates that the business critical functions, to be more exact, maybe one business critical function on one department is still not functioning properly, basically because of the deadlocks. And now we move all the resources for that problems investigation just to find out what really happened, because we have all the monitoring in place, right? We have everything at our hand to investigate what went wrong. And after doing more investigation, we found out that actually the network was the biggest problem. And why the network? Why this problem appeared only after the migration? Because the bare metal servers were in the Poland, while our AWS, all the resources were in the Germany. And while geographically, this isn't very big distance, right? But still that caused 15 to 30 milliseconds lag inside, between the queries. And while having this lag and while having 1,000 queries per second on the database, in the MySQL database, this started stacking up the deadlocks and started locking the transactions. And that's why we decided to roll back the central MySQL back to the on-premises. And one of the problems with the MySQL, what we found out later on, is that the InnoDB engine on the 5.0 version is doing pretty interesting thing. It actually locks the row while reading it. And while having 1,000 queries per second, it actually stacked up all the deadlocks, all the transactions into quite a queue. And after the migrating, you know, we also did the plan. At the end of the day, while having a window for the MySQL, we migrated MySQL back to the on-premises. And this still left us with all the PostgreSQL databases on the AWS side. So we're still not at the step which we began with, right? And now let's fast forward 2 months, right? It's a bigger step now. We had a post-mortem meeting to not only investigate, put up the points, what went wrong and what could have done differently, but we also changed the definition of done. The definition of done of the migration. Because initially, if you remember, the definition of done was to migrate it fully, right? But after having this infrastructure, you know, the hybrid architecture, we found out that it's actually also working pretty well, and migrating that one Django system, which is on bare metal, would take way too many effort and costs to migrate it to the AWS, and still while having it into AWS would not make such a difference for the full platform. So that's why we decided to adjust and to change the new goal for our migration to have it a hybrid architecture, right? To have MySQL and one of the oldest platforms on the on-premises, while keeping all the new platforms and PostgreSQL databases on the AWS side. So we migrated the majority of services to the AWS and Kubernetes gradually. Since we had all the databases on the AWS, starting up new Kubernetes nodes and launching them up to the database was pretty easy. We just launched a new domain, left for the client to test it out with the proper loads for specific for departments, and after verifying that, reroute everything to the new infrastructure. So this was done pretty easily and gradually. We stabilized hybrid infrastructure and optimized cloud costs so that by the end of the day, the client would still save the infrastructure costs, and we succeeded in that. So the lessons, the most interesting slide, right? The lessons which I knew, I wish I knew them before. Firstly, more monitoring and investigation. As soon as you think that you're ready for the migration and you're feeling pretty confident, please dedicate additional hours. Have another discussion, have another discussion with the colleague, try changing point of view, try, I don't know, brainstorming, anything that helps. It will still help you to maybe find some points which you might have missed. Highlight main business critical points and monitor them. So have an action plan which business functions are the most critical and what is the action plan for them. So for example, in case they're not working, what you're doing then, you know? So this would definitely help. Gradual migration, so that's definitely now go-to. More stress testing, that would have helped. Consider hybrid architecture as the initial step. This would have helped us too. And network latency should not be forgotten. So now, very quickly about lifesavers of the migration. Sentry did a great thing with all the performance metrics, with all the data which is coming with the error, and with all the tracebacks, it really helped us well. Grafana, truly a lifesaver. AWS database enhanced monitoring. Actually, this was the thing which helped us to identify network latency, because it helps you to even slice the queries and to see how much of the time was dedicated to which query parts. Query, result representation, or initialization. Actions and communication plan. So the final result, migration is done, full visibility of applications and alerts, continuous delivery. Actually, it helped us to highlight critical functionalities for the client, you know, and their state that, for example, in case of additional small load, this would start dropping, you know, business critical functionalities. Open the pool of AWS services. So now we are in our hands to have all the AWS services to be used. Secure infrastructure with high availability. We did the audit after the migration, and the results were incompatible with the previous ones, and high availability. The fun thing about that is, since I mentioned that previously we had outages several a week, and after the migration, before the migration, we had a discussion with the client, you know, that the support plan might be needed in place to monitor the platform during the weekends, how to solve these outages. And after the migration, the client said, you know, it's not needed anymore, it's working well. So yeah, the sales team was not very happy about that, but you know, we're doing what's best for the client. So yeah, for the ending, very good quote. There is always something you might have done to prevent the bad or unexpected outcomes. Expect the unexpected. So actually it was said by me during the migration and at the end of the migration. And probably that's it. As I can see, already 25 minutes ended up. So thank you for listening, guys. I hope that you enjoyed my speech, and class dismissed.